I'm excited about this nugget, my friend, because we are going to get a chance to look together at VTEPs and the tables that love them. No, not that kind of table. We're going to be talking about the shared tables between ESXi hosts running NSX that are going to enable logical switch functionality. So I want you to think about this. After we install NSX as a service onto each of our ESXi hosts, our next key task is going to be to set up a VXLAN interface. This is going to be a virtual interface, which really shouldn't be any surprise. If we wanted to perform vMotion between a couple of ESXi hosts, we would expect to have to set up a VM kernel with an IP address, the vMotion service installed, and for that to be accessible locally or routable to other ESXi hosts that we want to perform vMotion with. Well, now we're talking about a different service. It's not vMotion, it's VXLAN. And the term for a VXLAN VM kernel adapter is a VTEP, the VXLAN tunnel endpoint, because it is at this virtual interface of ESXi that has the VXLAN service enabled and has a particular IP address bound to it that is associated with a port group that is attached to a network card that has egress to the physical network, that we're able to encapsulate and de-encapsulate the messages that our virtual machines are sending. So all of our ESXi hosts will need to have VTEPs configured with IP addresses that are accessible to each other, either locally or routable. So how do ESXi hosts know how to forward machines from one ESXi host to another? Let's take a look at this example. So virtual machine A wants to send a message to virtual machine C. That communication frame is going to be passed down to ESXi1 to its logical switch, and now it has to figure out how to forward it. Is it going to be forwarded internally, like this one to virtual machine B, or is it going to have to go out on the network and be encapsulated and then de-encapsulated by another VTEP? And if so, which one? Which one of these ESXi hosts that are a part of my network happen to hold virtual machine C right now? Remember, this could even change because of vMotion. The way that our hosts will know is because of a set of tables that define the linkages between our virtual machines and the VTEPs that are supporting those virtual machines. There are three key tables that are held on each ESXi host and are also going to be found in our controller cluster if we define one. They are the ARP table, the MAC table, and the VTEP table. Each one of these tables is created per VNI. Therefore, in this scenario, we would expect ESXi 2, 3, and 4 to have one set of ARP, MAC, and VTEP tables, but ESXi 1, since it is supporting hosts on two different VNIs, would have one of those tables for VNI 5000 and another set of these tables to support VNI 5001. So with that said, what do we expect to see in those tables? First, let's talk about the VTEP table. This will be populated with entries that define the VTEP. What triggers the population of this table? Well, internally, when the first virtual machine of a particular logical switch boots up, then an entry will be added to the VTEP table for that VNI. So in this situation, when virtual machine A boots up, we would expect to see the VTEP table for VNI 5000 will have an entry indicating ESXi1 at 10.10.10.11 and its MAC address are now up and supporting VNI 5000. What happens when we boot virtual machine B? Well, nothing. ESXi1 is already an entry in that table. But what would happen when virtual machine C boots up? Well, then we'll have an entry added for ESXi2. Now, initially, of course, these entries are localized to the host on which they reside. How are they going to be interchanged? That's going to be based upon a replication method that we'll look at in a little more detail, but short answer is it will either be multicasted or there will be a common table distributed from the control cluster that will be used to keep everyone up to date. Now, what other entries will we expect to see as we booted up virtual machines A, B, and C? Well, in the MAC table for VNI 5000, we'll automatically have entries created. What's going to be associated with each of those entries will be the VTEP's IP address and MAC address. And what's going to keep this table uniform across all the ESXi hosts? Either multicasting between the hosts or use of the control cluster as a place for a common table to be aggregated and distributed. Finally, we have the ARP table. Now, to talk about the ARP table, let's envision an ARP scenario. Virtual machine A is going to try and resolve the IP address of 192.168.1.6 virtual machine B, and in order to do that, it's going to send out an ARP broadcast. Broadcast being a type of BUM traffic, broadcast unknown unicast or multicast. When that broadcast goes out into the logical switch that ESXi1 is managing, ESXi1 is going to have to figure out what to do with it. And in the case of an ARP, it's going to check the ARP table to see, can I go ahead and answer without having to spread that traffic around? If the answer is no, there's nothing in the ARP table to begin with, then ESXi1 will in fact have to forward that traffic on encapsulated and send it on to each of the other members of the logical switch. But NSX is smart enough to know that that's just one message per VTEP, not per virtual machine. Just like in destination devices, the logical switch is going to learn something even from this broadcast, because that broadcast announces that 192.168.1.5 is available at MAC address AAAA, and that entry will be specifically placed in the ARP table, along with the VTEP identifier. And when virtual machine replies back to virtual machine A, the switch will be able to reference immediately, straight out of the MAC table, which VTEP that's associated with, and be able to forward it appropriately. In the process of that reply, the logical switch will also learn that 192.168.1.6 is hosted on the MAC address that ends in BBBB, and that will be added to the ARP table as well. Soon we'll also learn about the identity of other devices on the network, because as we said, ARPing happens early and often. So later when these ARP entries come in from one VM to another, instead of having to forward the ARP request as a broadcast throughout the network, we can quickly resolve that from the local ARP table, which is shared through the process of broadcast or through a central lookup against the control cluster nodes. So with these three tables, we now have the tools to connect our hosts, to connect our VMs, and to speed up the process of ARP communication, reducing broadcast traffic in the network. Now before we close out of this, I mentioned that in this example we were looking at a couple of different VNIs, 5000 and 5001. And I just want to mention that it's probably going to happen at some point that you're going to want to be able to route in between those different networks, and to do so we will set up a distributed router, another service running on the ESXi host. Since it's not a physical router, it's not even a virtual machine edge router, it's a distributed router, that means we'll need another distributed table between our VTEPs. So to support inter-VNI routing, we're going to need a routing table with the different internal subnets that are available to route on any particular ESXi host defined so that they are commonly available throughout all ESXi hosts participating in those VNIs. By going through this nugget together, you've learned what the VTEPs are and what the tables are that interconnect those VTEPs and support communication between those VTEPs. I hope this has been informative for you, and I'd like to thank you for viewing.